Okay, well, every day when you come in, there will be a question waiting for you on the Socrative app. This is the one that was coming in today. It's usually, not always, but usually kind of just a review question from the previous class, just to see how we're doing, how we remember using our calculators, going through calculations and such. So let's just see here how we did. We'll get the answers logged in. We'll count down 5, 4, 3, 2, 1. Correct answer here is C, 6.7 times 10 to the 54th. If you were to go through and plug this into your calculator, remember that the way that we do that looks something like this. And we have the 4.4 times 10 to the 22nd over 6.6, what was it, times 10 to the negative 33, and then equals. So when you plug this into your calculator, it's going to be 4.4, and you'll hit that EE button, 22. Then we're going to divide by 6.6. You'll hit the EE button, and then your sign changing button, 33, and then enter or equals or whatever it is to execute that calculation. If you're doing it any other way, unless you have a TI, you had the TI multi-view, whoever had the multi-view, I don't remember who it was, or a TI 34 that handles it a little bit a different way. So make sure though that you know how to use that EE function on your calculator and the sign changing button. Otherwise you're going to end up getting wrong answers, as did how many people here? Probably about 27% of you got that wrong. So, any questions on this one? Any questions? All right. Well, as I did mention the other day, I don't go through this the entire semester. For the first 2 weeks, I will go through kind of a little heading here, just reminders, but after this week, I don't. Where do you find deadlines? Syllabus, exactly. Where else are you going to find them?
On the calendar online.
On the calendar online, on D2L. So it's there. You don't need me to remind you. You guys want to be responsible adults or whatever else. So be responsible and look at your deadlines and such. So the first reminder is that there's a syllabus quiz that is on the back page of your course syllabus. Remember that the first piece of that syllabus quiz is to do the email, which is due on Thursday. Once you do the email, then you go to D2L Brightspace and take the quiz that appears on there. And in case you forget, there's a little prompt on the D2L quiz there that reminds you, hey, by the way, you're supposed to send that email first before you take it. Then you've got the Master Chemistry homework quiz, which is due this Friday as well. We have extra credit practice problems, and where do we find the extra credit practice problems? Master in Chemistry. Any questions on the syllabus? Can I ask one more time on Thursday? So any questions here today? All right. Last week in lab was the required safety training. Some of you have already had lab twice. You have lab on Mondays. The other half of you have lab on Thursdays at 10 o'clock. If you have lab on Thursdays at 10 o'clock and have not yet done, well, regardless of which lab section you're in, if you have not done your safety training yet, it is required by law and it must be completed before doing lab activities. If you are in this situation, please talk to me after class to make sure you get that lab training completed and you can participate in lab. Lab is a mandatory part of this course. If you don't participate in lab, your letter grades will either drop or you will fail the course. So the required safety training has to be completed before you do those lab activities. Do remember that starting with your lab this week, you must complete a pre-lab quiz in order to participate in lab with a minimum score of 2 out of 3. And then we do have the Socrative app, which you should have installed and open, and there will be a question waiting for you. Unless something happens, like get stuck behind a train or something coming in, though even then I get here by like 6:30 or whatever. But there should usually be a question waiting for you on the Socrative app each day you come in. So any questions before we begin here today? Any questions? All right. And of course now I forgot my stuff sitting in my office. I'll just bring another one of these out. I think it's about the same size, but I measured, and I suppose my ruler's in my office too. We can pull this one out here to look at. I have an index card here, and I had gone through before class and just made several measurements. And I'm laying it out here. Here we go. Now I know sometimes students are going, what the heck? So camera right up there, just in case you're wondering what goes on. And so when I demo stuff, I will bring it out here and put it under the dot cam so you can see. And if we look at this particular ruler, this is like the one in my office. If we look at this ruler, anybody know what units this is measured in? If this is 30 and this is 40? Centimeters. So if it comes out to here, then it's going to be 31 centimeters, 32. If it's halfway between here and is right on this mark, it would be about 30.5. And now, of course, because the divisions here are by tenths, that means we should be able to estimate to the nearest, how much? Nearest hundredth. So remember we talked about that the other day. We look at our measuring instrument and we always try to estimate one digit beyond the smallest division, because the last digit is always going to be one that is an uncertain digit. So that means I should be measuring this card, if I'm going to be doing it, I should be measuring this card out to the nearest hundredth of a centimeter. Now, sometimes you never know, like when these rulers are cut off or whatever, how they lie. So many times I recommend that when you take a measurement on a ruler or something like this, is that you lay it down here in one end right on the mark, and then come down here and measure the length here on the other end. And so you can see here, if I'm on 20, and this is coming up to be a little bit less than 31, and I did this before class. If I went further up here, it's going to be somewhere between about 10.7 and 10.8 for the width. And we can do the same thing here by laying it out and measuring that length. So having done that here before class, these are the measurements that I took for the length and width. And for the length, we have a measurement of 13.95 centimeters. For the width, we have a value of 10.73 centimeters. Now remember again that the last digit in each of these measurements is called uncertain. So that means, of course, if I were to repeat this, maybe the next time I'd come up with 13.96 or 94 maybe, and maybe this time I come up with 10.74 or maybe 72. The point is, again, is that this last digit is going to be uncertain. So I could measure it a few times and maybe come up with something like this as a set of results. So let's say I went through here 3 different times and came up with these measurements. And again, underlining the uncertain digit in each of these measurements. And now if we have these values, we have the length and width, let's go ahead and calculate the area. So take your calculator, and if you don't have a calculator, you can come up and borrow one from me. But let's make this quick, please. Come up with your collateral if you need one. I usually do this before class. I forgot today. Thank you. Thank you. Anything else? Thank you. All right, thank you. All right. So let's go ahead and calculate the area. And if we calculate the area given the length and width, what operation are we going to use?
Adding.
Adding or multiplication?
Oh, for sure.
Multiplication, all right? So we need to multiply these two together. So let's go ahead and calculate the area for each one. Let's write down all of the digits that your calculator gives you. Write down all of the digits. So I'm going to take 13.95 times 10.73. And my calculator is showing 149.6835. Next one I have 13.96 times 10.74. And I'm getting 149.9304. I'll take 13.94 times 10.72 and get 149.4368. And then the last one will take 13.94, multiply it by 10.73, come up with 149.5762. Now, these answers are not yet acceptable. What's one thing that's missing on these? Units. So what are the units on these? Centimeters squared, exactly. They're not centimeters. If you take centimeters times centimeters, you get centimeters squared. Just like if you take 3 times 3, you get 3 squared, okay, or 9. So again, if we take centimeters times centimeters, that means that the units are centimeters squared. Now, when we want to look at these answers, the next thing we'd like to do is we'd like to figure out how should these answers be rounded. Well, when we look at a value, how many uncertain digits should there be? 1. So we want one uncertain digit. So if we want one uncertain digit, then we come back and ask ourselves, is the hundreds place, the 100s place, a certain digit? Is the tens place certain? Is the ones place certain? Is the tenths place certain? Is it certain? Well, no, because what's happening here to the tenths place? They're all different. So here they were the same, here the same, here the same. These here now are all different. So that's telling us that that tenths place is the uncertain digit. So going back to where we were then last week, we define the significant figures. Let's see here where we had that definition. I don't quite remember. Here we go. The significant figures are all of the certain digits in a measurement plus one digit that is uncertain. So again, the significant figures are all of the certain digits in a measure plus one that is uncertain. So what we've done here is we've underlined the uncertain digit. And anything after that we should not be retaining as a part of that measurement. So consequently, this first one here, we should round off to 149.7. The second one should be rounded off to 149.9. The third one should be rounded off to 149.4. And the last one to 149.6. So if the digit after the one we want to retain is 5 or greater, we round up. If it's less than 5, we round down. So again, we rounded up here on a couple of them because again, we look at the digit that comes immediately after. If it's a 5 or larger, we round up. And so this is the way that these would be rounded off. Now, one of the things that you ought to notice when we do this, we count significant figures. How many significant figures does this measurement have? 4. This one has how many? 4. Turns out our answer has 4 significant figures. And so if you think about going through your math classes when you've done this before, you've maybe not thought about significant figures. You've maybe thought about decimal places. You might have looked at this as having 2 decimal places, this having 2 decimal places, and then this one having 2 decimal places. That doesn't work with multiplication division. With multiplication division, we look at significant figures. And so we have some rules that we're going to look at for rounding. They go like this. And this now is if we're dealing with multiplication and division. And what we say is that your answer should be rounded. Your answer should be rounded so it contains the same number of significant figures as the measurement having the fewest significant figures. So again, your answer should be rounded so it contains the same number of significant figures as the measurement having the fewest significant figures. And so coming back to our measurements that we just looked at here, if we count significant figures, this measurement had 4, this one has 4, the fewest of 4 and 4 is 4, which means the answer should have 4 significant figures. If, for example, let's say it wasn't 13.94 but 13.9, then this measurement would have had 3 significant figures. This would have had 4. The fewest of 3 and 4 would be 3. And then we round this answer off to 3 significant figures. So again, that's how the rules work for multiplication and division. Any questions on that rule? Okay, then we have a rule for addition and subtraction that looks something like this. And this is where I bet you wish you had a tablet PC. I'm going to copy this one if I find my copy command. We'll come down here and we're going to paste that. How about that? Paste right there. And now I'm going to change this just a little bit. The way I'm going to change this now is I'm going to change this to be no longer multiplication and division, but addition and subtraction. It turns out that I just need to change a couple words in here. I'm going to get rid of significant figures. And I know if you've done your homework, you've seen this already. And I'm going to replace the significant figures with the word decimal places. So it's going to be decimal places. So it's basically the same definition, but instead of dealing with significant figures, we deal with decimal places. So what it reads then is that your answer should be rounded so it contains the same number of decimal places as the measurement having the fewest decimal places. Your answer should be rounded so it has the same number of decimal places as the measurement, the fewest decimal places. So if we then went and looked at an example of where or how we might use this, let's take these numbers, 385.17 meters, 6.2 meters, and 45.76 meters. Let's go ahead and add these together. So again, 385.17, 6.2, and 45.76. Summing these together, my calculator is showing 437.76 0.13. The label on this is going to be meters. Now, from here, we go ahead and apply our rules. How many decimal places does this first one have?
2.
2. Second one has how many? 1. And this has how many?
2.
The fewest decimal places is 1, so our answer should have 1 decimal place. How would we write this answer then? 437.1 is the way that we write that value. Now the reason for that is we go back and we ask yourself, what is the implied uncertainty in each of these measurements? So if I come back to this first one, what is the implied uncertainty in this measurement here? Okay, it's the 7, that's the digit, but what is the implied uncertainty?
6 to 8.06 to 0.08.
It could be 6 to 8, but we'd represent it as plus or minus 0.01, right? For the second measurement, we'd represent it as plus or minus 0.1, and for the last one, we'd assume plus or minus 0.01. So again, in the absence of information, we would assume an uncertainty of plus or minus 1 in the last digit. So if we think about it on this first one, I'm going to go back and write all of the digits we had in the measurement. This is what it looked like before we rounded here. If we think back now, we said that the 7 maybe could have been a 6 or it could have been an 8, in which case, which digit would have changed here in this answer? It would have been the hundredths place. It would have been the last one. Okay, so we know already that the last one would have been affected both by this one as well as the bottom one, because again, changing this digit right here winds up changing this one down below. So we'll go ahead and put that back in there. But if we go to this one here now in the center, the plus or minus 0.1, if we repeated it now, instead of 6.2, say we wound up with 6.3, notice now that this would change this answer to be 437.23, telling us that this here is the uncertain digit and is the one to which we would round. And so that's why the rules here for addition and subtraction are different than they are for multiplication and division. So let me just go back here and make sure that I put the right thing in. And again, if we were to record this answer, we would correctly record it as 437.1. Now, in your textbook as you go through these problems, you're going to be asked in the first few to round it off to the correct number of decimal places or significant figures. And that's just to get you in the habit of it, asking what those rules are. But after you go beyond those rules, then what you'll need to do is just use the rules. You're not going to be told, if you go through and look at problems in chapters 3, 4, 5, 6, whatever, it won't say round to the correct number of significant figures. It's just expected that's what you'll do. So we spend the time here learning the rules at the beginning, and then you'll be applying them the rest of the semester. All right, so any questions do you have on those problems? Okay, let's try these. These are going to show up next on the Socrative app. Let's take 162.110 grams and divide it by 8.35 milliliters. Give your answer to the correct number of significant figures. Then on your next one, let's take 275.71 kilograms and subtract from it 8.4 kilograms and express the answer with the correct number of significant figures or decimal places. And once you get that, then I do have a kind of a rectangle we're going to look at. almost a square, and it has these dimensions, 44 centimeters by 43 centimeters. Calculate the area with the correct number of significant figures. So the first two, though, will appear on the Socrative app. So I'm going to put the Socrative app back up here. If you are not in there yet, you can get back into the Socrative app. Don't just put your answers in. Talk to a neighbor first, make sure you're in agreement, discuss it, and then commit. I ask you to do that on all of these here this semester. Talk, because when you talk it out, you might find out that you actually are thinking about it incorrectly. So talk them through. We'll give you about 2 or 3 minutes here. The first one's loaded into Socrative already. It's Oscar Matumbo here. Brooke. Dennis. Travis Waldrop. Siobhan Spinner. Devontae Torrey. Remember to talk these through. Don't just blindly do it, because there's often a chance you're not sure. Get some affirmation from a neighbor. If you have this one entered, be working on the next two. Be working on the next two. Correct number of significant figures.
Number 2, did you guys get 267?
Going to give you about 30 more seconds on this first one. About 30 more seconds.
You get 267.3.
Yeah.
It will take about 10 more seconds. Get your answers locked in here. We'll count down. 5, 4, 3, 2, 1. Correct result is 19.4 grams per milliliter. Okay, now, how many significant figures in the numerator? 6, because trailing zeros count, right? There's 6 significant figures. How many in the denominator? 3. So what do we do if we have 6 and 3? Use 3. We look at the one that has the fewest. The fewest significant figures is 3 significant figures.
I was looking at the decimal.
This one right here has 3 significant figures. When do we look at decimal places?
It's plus or minus.
When it's plus or minus, exactly. So you're in luck. The next one has plus or minus. Take a look at your rules. And get your answers locked in here, please. For number 2, get your answers locked in. And if you have that answer calculated, go on and calculate the answer for this last one with the correct number of significant figures. All right, we'll count down on this one. 5, 4, 3, 2, 1. Correct answer there. We did a little better. Of course, this is the one you're more accustomed to. This one here, we don't look at significant figures, but we look at decimal places. How many decimal places in the first one? 2. This one has 1, so your answer should have 1 decimal place. And here's the one here that has a 1 decimal place. We'd record this one here as 267.3, the label kilograms. Okay, let's do the last one here. Anybody think they have the area with the correct sig figs in? Yes, go ahead. 1.9 times 10 to the third. Do you have a label for us?
Centimeters squared.
Okay. Any other possibilities? Any other possibilities? This is the correct answer. Now, how is it correct and why do we put it this way? Well, first of all, if we take 44 and multiply by 43, we wind up with an answer of how much? 1892. Okay, and the label on this would be centimeters squared. Okay, so we multiply 44 times 43, we get 1892. Of course, now we look at this, do we say this has how many significant figures? 2. This has 2. The fewest of 2 and 2 is 2. So then we come back and say, well, how in the world do we round this off to 2 significant figures? Well, if it's 2 significant figures, that means that this here is the uncertain digit. One of the mistakes I often see is I'll see this rounded off to 19 square centimeters. That's incorrect because 19 and 1900 are a huge difference. But it is the 9, we do want it to round to 9, but we have to remember that there's going to be places that are after here. So we round it off to 1900. If we see the 1900 though as an answer, 1900 centimeters squared, we still don't know whether these zeros that are trailing are significant or not because this number has no decimal place. So if we want to clarify then if any of these zeros, trailing zeros are significant or not, then we do need to put it into scientific notation and we write it like this. And so many times I'll hear students ask, well, why does your book have it like this? Or why does Mastering Chemistry have it like this? It has to do with the fact that we don't want to show, like writing it like this would show ambiguous zeros at the end. We don't know whether they're significant or not. And writing it like this shows a level of precision that does not exist. Okay, so any questions? Any questions? Okay, next up, we have a couple of figures that are in our text. I am curious, how many decided to go with the e-text only option in here? Any of you do that? Nobody. You really want to carry books around. We tried to save you money, okay? But if you were to look in your text, you're going to see some tables here, one on page 26 and 28. The one that's here on page 26, this is what we refer to as SI base units. First of all, anybody know what SI units are? If we use the term SI, what that stands for? You see SI here and SI there. SI stands for the International System of Units, which is another name for the metric system. Okay, it's another name for the metric system. And in this actually comes from the French interpretation, which isn't the international system. I can't pronounce it, but something like Système Internationale. Okay, I don't know. It's probably really bad. Okay, but what it is anyhow, it's from the French interpretation of the International System of Units, which came about as a way to standardize units of measurement. The U.S. is the only major country in the world that hasn't adopted this as their standards. If you go into any other country, even if you go across the border to Canada or Mexico, you'll see, and I've been to Puerto Rico, which is a U.S. territory. We have them listed in the metric system there, or SI units. But these here are what we call the SI base units. Now, when we talk about a base unit is a unit that we can pretty much make all measurements. In other words, all measurements can be measured in base units. And so as you look at these here, you'll see length, mass, time. Very often, students think of SI units as being, of mass as being the gram, but it's not the gram, it's actually the kilogram. Okay, and this one is often mistaken. The base unit of temperature isn't the Celsius, it is the Kelvin. And one of the reasons why a Kelvin is selected, we'll be using kelvins throughout this course, but kelvins is used because the Kelvin temperature scale has no negative values. So the Kelvin temperature scale only has positive temperatures. And another base unit that we'll be using here a lot is amount of substance. Amount is another base unit. Where did those other letters go? I don't know. I'll write it in again. Why is that doing that? I don't know. We'll put in the word amount here. And amount is measured in units called the mole. And the mole is abbreviated MOL. And if you haven't had any chemistry before, the mole is going to be something new to you. It's not the furry little critters that dig up underneath the dirt. Okay. The mole is kind of the chemist, we could say the chemist doesn't. But we'll talk about this. There's actually a couple different base units. There's one they call electric current and luminous intensity. There's actually 7 different base units. In this course, we use these 5 different base units. Now, one that you're not going to see up here is a unit of volume. And that's because a unit of volume is not a base unit. A unit of volume is actually what we say is a derived unit. So, for example, if you want to take the volume of something, a volume has how many dimensions? 3 dimensions. And if we want to find the volume of a box like this, how would we find its volume? Length times width times height, which are actually all which type of these base units? Well, a length, a width, and a height are all length measurements. So basically, if we take a length times a length times a length, a length times a length times a length is going to give us units of volume. And if we take a length times a length, we get units of area. We've already did that today when we talked about the area of the card. So those are examples of derived units. When we take combinations of base units and create a new one, those are what we refer to as a derived unit. And so volume is an example of a derived unit. Volume, again, is an example of a derived unit. And so if we looked at something like the SI unit of volume, and I'm going to come down here a little bit, look at this a little bit more detail. If you were to draw this out, let me kind of start here from scratch on this, so you don't need to write all this down. We'll kind of work through this. And I'll help you draw a box if you're not capable of or haven't written many before. So if we want to create a box, the way that you're going to do that is you can draw a square like this, and then you're going to draw a square that's offset. Now understand this is coming from a non-artist, so if one non-artist can do it, then other non-artists can. And basically you connect these corners together. And if we want to talk about the SI unit of volume, the SI unit of volume is the cubic meter. It's a cubic meter. Now if you think about this as to what a cubic meter is, this here represents a meter right here. This is what a meter looks like. And if we had a box that measured 1 meter by 1 meter by 1 meter, it would look like this much by this much by this much. So we're talking about a box that is looking pretty big. And that's a cubic meter. And a cubic meter would be convenient if we're shipping cargo containers or something, because again, the volume in this is going to be 1 cubic meter, but it's not going to be something that is very convenient for putting stuff in the refrigerator, like this size might be. So what I'm going to do here with this is I'm going to take this box and I'm going to copy this box and paste it because I don't want to write it out twice. That was too good. So we'll copy that and we'll paste it right here. There we go. But now, if I look at this box, what I'm going to do with this box is actually measure it this time. I'm going to measure this box. And when I measure this box, let's pay close attention to what the size and dimensions would be. Now, these are more exact, so we should be able to see an estimate from here about how many centimeters is this. It's 10. So this is 10 centimeters by 10 centimeters by 10 centimeters. Now 10 centimeters happens to be the same as 1 decimeter. So this is actually 1/10 of a meter. This is a meter stick, and so this measures 1 decimeter by 1 decimeter by 1 decimeter. So if we come back to this box and look at it, again, it's showing 1 decimeter by 1 decimeter by 1 decimeter. This box has a volume of 1 decimeter cubed. And it turns out then what we've done is we've redefined a cubic decimeter as being 1 liter. So if you're wondering where the liter comes from, turns out that a liter is the same as 1 cubic decimeter. Okay? And this is something that's more convenient refrigerator size as compared to a cubic meter, because in SI units, a cubic meter is going to be a really, really big box. So this is something that's more convenient. But remember that these dimensions here now, if we put it in centimeters, would actually be how many centimeters? 10 centimeters by 10 centimeters by 10 centimeters, which means that this volume is also equal to how many cubic centimeters? 1,000, exactly. So there's 1,000 cubic centimeters in this quantity. And turns out that there's also 1,000 of something, and this is kind of a cool little device. If I take this out, there's actual pieces that are in here. Each of these little pieces, if I were to measure each of these little pieces in here, measure 1 centimeter by 1 centimeter by 1 centimeter, which means each of these little cubes that I have up here have a volume of 1 cubic centimeter. Which means if I put these little cubes inside of this box, how many could I fit into here? 1,000 of them. So it turns out there's 1,000 of something else that fits in here. And what 1,000 of something else fits into here? Well, if we want to use the label liters, it's 1,000 milliliters that is in here as well. And so what does that say about the size of a cubic centimeter and a milliliter? They are the same thing. A cubic centimeter and a milliliter are the same thing. And of course, maybe you talking about engine displacement in a motorcycle as an example. We don't talk about cubic centimeters, we label it as cc's. And so they all represent the same thing. So what I am boxing right here, these are going to be your to memorize conversions right here. So the ones I've boxed is what you need to memorize. You need to memorize that a cubic decimeter is the same as 1 liter, or that a cubic centimeter is the same as 1 milliliter. So those are conversions that we will typically wind up using. And what's kind of interesting to note about this is that many times the cubic centimeters and the milliliters get mixed up with each other because of the fact, if we look at these metric prefixes, the prefix centa means 100th, the prefix milli means 1,000th. And it's kind of because what's happening here is we're mixing up some units. This here is a length cube. Well, this is a prefix applied to volume. And so it turns out back in the days that I was working as a student, when I was working as a student, I have an old syringe here. In the medical world, your syringes were measured in units of cc's. Now, of course, what happened is because people would get centa and milli mixed up in these conversions, very likely you could wind up giving a patient an overdose. So if you go into hospital setting today, instead of cc's on your syringe, now of course you're not going to inject the patient usually with this much unless it's in an IV bag, but today the syringes are labeled with units of milliliters. So you go into the doctor's office and you're going to see a difference between them, and the reason why they've gone to milliliters is to avoid this confusion between cc's and milliliters and the difference in prefixes, because in those former days there were more overdoses associated with the mixing up of those units. But you as students should still know that when you are talking about cc's or milliliters, cc and milliliter means the same thing. So we never change doses, but we change the way we represent them to avoid clerical errors and overdoses and such like that. Okay? Now, as far as some other things that are in this table here, you should know the prefixes that go in this range right here. These are your to memorize. Well, it's just about all of them now. Femto you haven't heard of a whole lot. You'll start hearing about femto like in femtoseconds. Right now, I think back to when I was a student, we pretty much learned these prefixes like kilo through micro, and that was sufficient. But in today's storage world, of course, storage, when I was a student on the little floppy disks, if any of you even know what they are, was measured in kilobytes, and they went up to megabytes. Then we have hard drives in gigabytes. Well, now we have RAM in gigabytes, and we're measuring hard drives in terabytes. Okay? Speed of calculations used to be in milliseconds, and they went to microseconds, and they went to nanoseconds. Today we're talking about them occurring in picoseconds, and probably in the very darn near future, you guys are going to start hearing about femtos as being an even faster way to look at those measurements. Yes? Now, all of them. Yeah, all of them. So when I say all of them here, what you're going to learn is you should learn the symbol that's used. You should learn the meaning. And that meaning, if you don't remember the word, at least remember the quantities here, either in their standard numeric form or as their exponential value of 10. What I will tell you is that very often the ones that are mixed up are the prefixes for mega, milli, and micro. And that's because they all start with M. So mega, we use a capital M, micro, the letter mu, and milli is the one that retains the lowercase m. Okay, any others? Any other questions? We probably don't use deca or hecto a whole lot, so if you didn't learn these, that's probably okay. I can't remember, to be honest. I'm not going to put those on the test or anything. They might show up in the homework. So if you're going to concentrate on them and you just need a little break in your mind, you maybe don't need to worry about the hecto one, deca. Though deca is easy because, of course, deca is like decade and it's 10. I mean, it's not that hard.
I just have a question. Is there a difference between centimeters squared and squared centimeters? Because I heard that there was, but I just...
We're not going to we're not going to distinguish in these because you have to be actually very careful on the vocabulary used, because I heard the letter D on the end when you said it. There's a difference between centimeters squared and centimeters square. If I talk about the dimension as being 10 centimeters square without the D on the end, that means it's 10 centimeters by 10 centimeters. If I say 10 centimeters squared with a D on the end, that means that I'm talking about a volume which you've already multiplied the dimensions together to get the 10. So your text does not mess around with that, but places you would is like if you were in the areas of construction or something, you're talking about the dimensions of something, you might talk about something as being 12 feet square. If it's 12 feet square, you're talking about a room that measures 12 feet by 12 feet. But its actual area would be 144 feet squared. So that's where you do need to make the distinction, but your author doesn't talk about that. We don't deal with that in here, but it is a good question to know. Good answer. Good question to know the answer to. Okay. Anybody else? Yeah, I think that's the first time in all these years I've been teaching I've heard that, but it's again an important distinction. Okay, so now I am interested to know actually how well we know some of these values and how they compare to their English units. So if we look at this meter right here, we want some approximation. Talk to neighbor, that's okay. What do you think this is closest to in terms of English units? What do you think this is closest to in English units? Because again, if you want to kind of get a handle on these and you want to go or compare to what you're comfortable with, what is it closest to in English units? And we'll go ahead and lock in your answers here. We'll count down. 5, 4, 3, 2, 1. It is the closest to the yard. The yard is how many inches? 36 inches. A meter is a little bit more than 39. The meter actually came originally from being like 1/10,000,000th the distance from the pole to the equator. So there was a different standard that was used for it. This one here is a liter. Take a look at it. What is this closest to in terms of English units? Is it closest to the cup, pint, quart, or gallon? What is it closest to? And we'll get our answers locked in here. We'll count down. 5, 4, 3, 2, 1. It's actually closest to a quart. A liter is actually a little bit more than a quart. So if you buy a gallon of milk is going to have 4 quarts. In terms of the units, in liters, it's about 3.785. Now in your syllabus, you have a set of conversion factors. Let's go ahead and pull that conversion sheet out. Looks like this. Now this conversion sheet is something that you will always be able to use on your exams. You'll always be able to use this on your exams. And if you don't have your syllabus with here today, I always have extra copies of the periodic table. So I would say you never have too many periodic tables. You never have too many periodic tables.
Do you have any extra thank you.
Okay, so I'm sorry. Yeah. Okay, so now this is a sheet that you'll always be able to use on your exams. What you're going to see on here is a list of English to metric conversions, and you're going to see English to English conversions. The ones that are missing on here are we have English to English, English to metric. What's missing? Metric to metric. And that's because what are you going to do with the metric to metric conversions? You're going to memorize them. Because the metric to metric conversions are used for a number of things, units that you just can't list all the conversions for. But they're applied consistently. So when we talk about something like the mole, which most of you have no clue as to what it is, we can talk about megamoles, kilomoles, millimoles, and so forth. And so if you learn how to apply those prefixes, they are going to be able to be applied universally to a number of different metric units, and are always applied the same way. The English to English conversions don't work that way, nor do the English to metric conversions work that way. But the metric to metric always work that way. If you apply a prefix to a unit, they will always be applied in the same way. So what I should point out to you here when you look at these conversions is that your mass, length, and volume and area conversions here, these are good out to 4 significant figures. That means they could have a limitation on your calculations. Whereas your English to English conversions, these here are exact. If they are exact, this means they have how many significant figures? Means they have an infinite number of significant figures. And now not labeled on here is the temperatures. These temperatures here are exact conversions as well, which means that they have an infinite number of significant figures. And so on our first exams, these are going to be the primary, first probably 2 or 3 exams, we'll just be using these 2 tables here. So you should know that these are good out to 4 significant figures. All right, but if we go back now and try to say, how are we going to apply those metric prefixes that we are going to learn, we could wind up applying them something like this. So let's go now and go through a bunch of conversions. If we look at some conversions, and now you can have the conversion sheet that you have there, or you can have your conversion table for the metric to metric conversions out in handy. We're going to look at some examples to say, well, you already know some of these. For example, if we talk about the relationship between dollars and centidollars. Now, of course, you don't call them centidollars, you simply call them cents. But if I had $1, $1 is how many centidollars? 100. 100 cents is $1, right? And if we had 1 centidollar, that is 1 cent, 1 cent is how many dollars? 0.01 dollars, okay? Now, of course, Americans, we tend to put the dollar sign in front. But I mean, we already know these conversions right here. So if we apply these now to some metric units, let's say that we had 1 meter, and we'd like to know how many centimeters there are. How many centimeters would there be? 100. Just like there's 100 centidollars, or 100 cents in $1, there's 100 centimeters in 1 meter. Which means if we have 1 centimeter, 1 centimeter is how many meters? 0.01. Just like 1 centidollar is 0.01 centidollars. So we have that analogy. But it goes back to the meaning that the prefix centa means 1/100th. If we look at the prefix milli right here, the prefix milli means 1/1000th, or 0.001. Let's look at kilo. We're going to work with these 2 next. The prefix kilo means 1,000. So again, milli means 0.001. Kilo means 1,000. So now if we apply these, we want to look at the relationship between liters and milliliters. And if we have 1 milliliter, express this in units of liters. And likewise, if we have 1 kilogram, we want to express this in units of grams. Or if we have 1 gram, express this in units of kilograms. So now, here's how these conversions work and how you should never, ever, ever mix them up. Because what I'm going to tell you now about metric conversions works for all types of conversions, whether it's English to metric or English to metric or whatever. It always works. And it works like this. First of all, if you see a couple of units and you're feeling like you have no clue, the first thing you're going to ask yourself, and that's why I asked, first of all, you know, this is equivalent to what the newest units. Think about how big they are. So, let's say that you're thirsty. You're thirsty, and I'm offering you some water. You've been out running. I'm going to offer you a milliliter of water or a liter of water. Which one do you want? Liter. Why do you want a liter? It's more. Even if you don't know how big it is, I think all of us, even if we don't know their relationship, know which one's bigger if I offered you one or the other. So if you can ask yourself right away which one's the bigger unit, then you should be able to apply the numbers. As long as you know the prefix milli means 1/1000th. And the way it always works is this, is that the larger number always goes with the smaller unit, and the smaller number always goes with the larger unit. Always. If you think of like the relationship between inches and feet, which one is bigger? Feet. Which means that there are more inches in 1 foot. Okay, so the big number always goes with the small unit, the smaller number always goes with the larger unit. So if that is said then, and again, think about yourself running and being thirsty. If I'm offering you water, you want a liter because it is bigger or more. Then if I have 1 liter, that means that if the liter is a bigger unit than milliliter, that means that this number here is going to be bigger. So what bigger number should go in there? 1,000, right? Because 1,000 is the reciprocal of 1/1000th. And if I have 1 milliliter is going to be how much of a liter? 1/1000. It's going to be 0.001. Because that's what milli means. Milli means 0.001. So the larger number goes with the smaller unit. The smaller number goes with the larger unit. It doesn't matter whether you write it like this or like both of these conversions are correct. But if you had written a conversion that said 1,000 liters is equal to 1 milliliter, this here is not a correct conversion because it's showing the bigger number with the bigger unit and the smaller number with the smaller unit, so it doesn't work. So again, if you can think about the size of it. Now if you go to the next one, I'm offering you some gold. Okay, I'm going to give you some gold. Do you want a gram or do you want a kilogram? All right, write down the conversions for the next one here. Fill in these blanks. Talk with the neighbor. I'm giving you gold. So then ask yourself, which one is the bigger unit? Remember, the bigger unit gets the smaller number. The smaller unit gets the larger number. So the first one is 1 kilogram is 1,000 grams. 1 gram is 0.001 kilograms. Any questions on these two? Okay, next up, we're going to look at dimensional analysis. Dimensional analysis. Now, dimensional analysis is exactly what it says it is. It is an analysis of dimensions, or analysis of units. And when we work with dimensional analysis is something used throughout our text. It's basically a way that we analyze units, and it all is based on multiplying together fractions. So, for example, if we had something like 3/4 times 4/7. If we wanted to simplify this answer, make this calculation faster, what do we need to do here? Cancel out the 4s. Of course, they don't disappear. They reduce down to 1/1. We wind up with an answer of 3/7. So now if we used a similar scenario and we took feet times inches over feet times centimeters over inches. The units we're going to wind up with in this case will be centimeters. We wind up with centimeters because feet will cancel out, inches cancel out, they all become 1 over 1. So the units on this one wind up being centimeters. So then, if we go from here and we say something like, well, let's go ahead and convert 42 inches to units of centimeters. We want to convert 42 inches to units of centimeters. What we do then is we come back to our conversions and we see that there's conversions. This is going to be an English to metric conversion. We're going to see that it is a conversion of length, and we'll see that there's 1 inch for every 2.540 centimeters. So we come back here and then we ask ourselves, how should we put that conversion in here? Because of course we don't want units of inches, we want to wind up with units of centimeters. So we need to use this conversion factor so units will wind up canceling out. So which of these units will need to go on the bottom to cancel out inches? Inches will need to go on the bottom, and the one that will need to go on the top is going to be the centimeters. So again, if you look at it, we have centimeters up above, we have inches down below. We set it up this way because we want the units to cancel out. And then we come back to our conversions and we substitute those in. And there's 2.540 centimeters for every 1 inch. So we put in 2.540 centimeters for every 1 inch. Well, inches cancel out, and now we just go ahead and perform the operation that's on our calculators here, which says we're going to take 42 and multiply it by 2.54. So we take 42, multiply it by 2.540, we wind up with 106.68 centimeters. Of course, now we need to take into consideration significant figures. We take into consideration of significant figures. How many significant figures does this measurement have? 2. This conversion, according to your conversion sheet, has how many significant figures? It has 4. So we come back here. This is good out to 4 significant figures. So the fewest of 2 and 4 is 2. This answer should be rounded to 2 significant figures. So that means it has to be rounded to which place? 1.1. It has to be rounded to this place right here. And so to write this answer out, we'd write it as 1.1 times 10 to the second with a label of centimeters. And again, we get it because we'd actually round this to be 110, and this here being the uncertain digit, and then we'd need to correctly write it over here in the scientific notation. Let's do another one. Let's convert your weight. Let's convert your weight to kilograms. Let's convert your weight to kilograms. And if you don't want to convert your weight, you can convert mine. Okay, but it's more interesting converting yours. So we're going to take mine though, and you want to use mine. My weight is 212 pounds. And again, you can put your number in if you want to put yours in. And we want to convert this to units of kilograms. Now if you want to convert it to units of kilograms, we go back and we look up the conversions. And we see there's a conversion here that says 1 kilogram is the same as 2.205 pounds. Now as a conversion, which one of these here is going to go on the bottom? Pounds, because we want pounds to cancel out. And on the top we're going to put in kilograms. As far as the numbers, what number goes in for pounds? 2.205. And how many kilograms is that? It's 1. So we put those in. Units of pounds here are going to cancel out. Once they cancel out, we take 212. We divide it by 2.205. Or you're going to take whatever your weight is, divided by 2.205. And now we ask ourselves, how many significant figures should be in that answer? It would be 3, because this number here has how many significant figures? 3. This conversion has how many significant figures? 4. The fewest of 3 and 4 is 3. So rounding this off to 3 significant figures, if you're doing mine, come up with 96.1 kilograms as the answer. And I always say if you're feeling a little chunky in pounds, just put it in kilograms, you're going to feel a lot better. Okay? Any questions on this one? Let's do one more here to wrap things up today. One more. Let's go ahead and convert meters to yards. And let's take something like 400 meters. Maybe some of you are in track and field. If you ran the 400, that's how many times around the track? It's 1 time around the track. In my day, we didn't run the meters, we ran the yards. So let's go and see how many yards this would be equal to. Now, if I put the decimal here, what I'm trying to indicate is that these trailing zeros are significant, so this number would have 3 significant figures. So if we come back to this one, we want to know how many yards there are. We start with the 400 meters, and again we're trying to get to yards. If you go to your conversions, and you're going to go to the English symmetric, you're not going to see a meter to yard conversion here. You're not going to see one here. So that means that this one's probably going to be one that requires 2 conversions.
Should we just do it by feet?
We could go by feet. If we went by feet, we can convert meters first to feet right here. So let's go ahead and do meters to feet. If we do meters to feet, what goes on the top? Feet. And what goes on the bottom? Meters. Do I go back and retrieve those numbers? How many feet do we have? 3.281. On the bottom, how many meters? 1 meter. And that comes from this right here. Then, at this point, if we cancel out units, this would give us feet. But one of the advantages of dimensional analysis is to set it all up in one calculation. So we don't need to stop here. We go one more. We now have feet. We can convert feet to yards. So we put feet on the bottom, we put yards on top. And we do have a conversion from feet to yards. So we come back and we see, where do we find that? English to English, right here. And it shows us that 1 yard is 3 feet. So where does the 1 go? On top. The feet goes on the bottom. Units cancel. Let's run that through and plug in your answer into the Socrative app, and that is our day for today. So again, I have it up on the Socrative app. Oscar Matumbo here today. Brooke Kennis here today. Travis Waldrop here. Trevon Stringer. Tamati Corey. Okay, who's seeing me after class? Oscar is. Molly is. Anybody else seeing me after class? I don't know your name yet. And Eric will. Yep, just see me after class. I know it's time to go here. If you answer this correctly, you should have with the correct number of significant figures how many sig figs? 3, which should be 437. 437. All right, that's it here for today.